Hey everybody, it's Check Defects coming at you with another Minecraft tutorial, and it's been a long time since my last one. I've decided to move my channel over from my old one to the one over here. When the whole thing when YouTube was acquired by Google type of scenario, and that's what's been the reason for my long sabbatical. Anyways, I am back and I am going to be bringing back some old tutorials as well as some revised ones of my old tutorials as well. So I hope you enjoy this, and we're going to be going over with my first tutorial in a long time. After the STP tutorial, you'll see my original design of the comparator STP, or signal to pulse generator. And that's going to be the first thing we're going to be going over is the basic concepts of a comparator clock. So without further ado, let's get to the tutorial. So as I mentioned before, comparators have been around since version 1.5, and we're currently in 1.8. So this, as of the date of this video, so they've been around for quite some time. So has this little invention of mine, the STP. And I just want to make sure that let you guys know that I am the original designer of this thing. So if anyone does have any questions about that, as far as the originality of this design, this is my original design. And the idea is very simple on this one, is that if you have a solid signal coming in, it lets out a pulse, right? And with the, you'll probably see me having put my episode 1, my original episode 1 from my old channel up for STPs and STP flip-flops, for the comparator version, that is. If you can, feel free to take a look at that if you want further information on the STP and the STP flip-flop. And what we're going to go here is the comparator clock, which as opposed to the STP having just one little pulse coming out when you have a steady input signal. If I turn this on with a steady input signal, you get a clocked pulse, or a repeating pulse, for this particular redstone contraption. And so let's go over how this works here. So you've got an input signal coming into a comparator, which then goes into a repeater and then hooks up to this other repeater, and that goes into this comparator. Also, you have a redstone output. So basically you have this repeater going into this redstone lamp. So your output can be either here, it can be over here, or here, or here. Heck, you can even have your output over here if you want to. Do not try to stick your output over here, because that would eventually cause a short and connect over to here, and that can screw things up. So in this case, what's happening is you have a signal coming into the comparator, which is less than the signal coming in on this side. So what happens is when the signal comes in here and the comparator activates, then you have that signal gets put into this particular repeater and it gets boosted. That signal then goes to this redstone dust and then this redstone dust and hooks up into this repeater and gets boosted again, so that you end up with a full strength signal, redstone signal, coming into this input on the comparator. What that does is it disables the comparator after it's been activated. So when that happens, the comparator is disabled, and then this repeater loses its power and it turns off, and then the redstone current turns off here, and it turns off in this repeater, and then turns off at this redstone dust. So you get a signal strength of 0 that allows for this comparator to be re-enabled again, because it's constantly having this solid state redstone signal into this input on this side. And now, just to let you know, you have to make sure that the signal strength that's coming in on the comparator over here has to be weaker than whatever signal strength is coming on here, right? So in this case, I have my signals that I have 2 redstone dust between the comparator and this lever to ensure that you don't end up with this thing not working at all. So I can put this further away if I want to, as long as the redstone signal that comes on this end of the comparator is weaker than the redstone signal on this side of that's coming out of this repeater and into this side of the comparator. And that's how your comparator clock works. So I hope you guys have found this informative. It's a simple little contraption that can have many applications, such as turning on when a particular, let's say a minecart has a detector rail, or turning on when you have a inventory block such as a dropper or a chest or a hopper whenever you have an item that gets in there, or any type of scenario where you want to turn a solid state signal of redstone current into a repeating pulse or a clocked pulse. If you guys want to see more, please subscribe and give a like. And if you have any comments or suggestions, please put them in the comments below. And this is Check the Effects signing off. Peace.